Okay, alright, people, this is Prof Manqanqa once again from Let There Be Tutorial, people. So we hear people dishing out knowledge, helping out others to, prosper, to conquer the challenge that comes with mathematics. So yeah, people, good morning, good afternoon, good evening, depending on whenever you're watching this video and wherever. So just sit back, people. Get a cup of tea, get a cup of water, and get yourself a notebook and just relax, people. Let us go through this journey, people. So this video, people, is one of the most important videos you will ever have to watch, people, under calculus, because everything builds up from, a lot of things build up from here, people. A lot of things build up from here, people. I believe you will see this as time goes by, as you continue exploring the vast, knowledge of a calculus. So, people, let's start out. So, the video is about people finding domain of any function, people, finding the domain of any function. So remember, we have defined what is our function. So if you maybe forgot, go back to our last video, the videos that we uploaded before this one, and then just find yourself through them, so that you know what do we mean when you're talking about function. And then now the new term that is now arising, people, it's what the domain. It's not really new, because in your grade 12 you weren't also introduced. So remember, people, the domain and range, they are similar, people. But the most important part of those questions that has to do with the domain and range, once you know how to find the domain, it's easier to convert that information to the range. So that's why, people, I'm not really giving you, notes maybe, or any information that you can use to find the range. Because once you master the domain part, people, I will help you through application, through doing certain example on how you can use that information to find your range. So sit back, people, get a, as I've just said, sit back, just relax, just focus, people. Just focus and give yourself, time to really grasp this concept, because this is where the calculus start, people. So then the question will be now, what do we mean when we say domain? And now, people, remember, what is a domain? A domain, people, what do we mean when we say the domain? The domain is what possible x values of a function, people, of a function. But I'm not just saying possible, all possible x values of a function. So this means it's where, and remember, our domain, people, we have our y axis, and we're going to be having our x, and then our domain, people, will be found where? People will be found here in the x-axis. So this is where the function will make sense, or where the function will be defined along x-axis. So we study these, people, because we have different types of function that also have different behaviors, people, and that have also different characteristics. So not all of them, they have what they have all of them, they have this, they have a positive, not really positive value, but they have values that make sense along what? Along our x-axis. So a function that don't have that, people, they have asymptote, they have also like x axis x our y axis also acts as an asymptote. So we'll see those things, people, those behaviors as we move along. So that's why it's very important, people, to see or to know, in fact, what is a domain and how to find it and how to really interpret it, people, the information, and how to present it. So a domain is what, people, these are all possible x values of what? Of a function, meaning it's where the function is defined. It's where the function makes sense. That is where you will find the function along x-axis. So we call that intervals where the function exists or makes sense or is defined. We call it a domain. So let's move on, people, and giving out the examples now. Okay, now then you say that, Professor Gutivele, these are all possible x values, but now how do we go about finding those ones? So I'm going to give you all the tools you will need to find any domain of the function, of the possible function that you will definitely maybe come across during your calculus test or exam, especially in your first year. So the first one, people, is what? The first function that you can be asked to find the domain is called polynomial. Polynomial function, people, are the function that have what, people, that have the positive powers. These are functions that have the positive powers, and they don't have what, people, and the powers, remember, the powers also, they are positive and they are integers, meaning are positive integers, meaning these are whole numbers. So for example, this is a polynomial function of degree 1. So it's raised to 1 and is a positive one. It's called a linear function, people. The other one, people, is x squared plus 3x plus 1. So this one is the polynomial function of degree 2. This one, there is an invisible one here. Can you see all the powers are of positive and they are integers, meaning they are whole numbers, people. So you must be careful on how we define polynomial function. We can also have this one, people. X to the power 4 plus 2x to the power of 3, maybe minus 1. This is also what? A polynomial function, but of highest degree of 4. So then, what is not a polynomial function? This is not a polynomial function, people. This is not a polynomial function. This is not a polynomial function because the power, people, is not of a positive number. This also is not what, people, is not a what? A polynomial function. This one is not what? A polynomial function, people. Because the power, people, is not of what? Of a whole number. It's of a decimal. The power is not a whole number. It's not an integer, people. It's 0.5. It's half. So we say that the powers, people, must be positive and must be a whole number. Are you with me? Let's move on now, people. On how do we find now the domain of the what? Of the polynomial function. So the domain of a polynomial function, people, is that this is for all. So here, people, is that all real numbers of x. So all the real numbers of x. So this means positive numbers and negative numbers, they are included in our domain. Meaning if you have now your function maybe drawn here, this one is negative and this one are positive, your function will exist from the here, the negative side of the number line, to the positive side, up to where? Up to positive infinity, up to where? Up to negative infinity, up to positive infinity. So it exists in all. It doesn't have any restriction, people. It doesn't have any behavior that cut off a particular section of our x-axis. So that's why we say the domain of the polynomial function are all the real numbers of x, people. So this means now it exists everywhere in our x-axis, people. So how do you write it? Because people they want it in different forms. You can write it in this manner. X is an element of real numbers, but they may want it in what the question may state that you must write it in what, people, in a interval manner. Then that's how you're going to write it. X is a what? Is a element of what? Negative infinity to positive infinity. And you must be very careful about your brackets, people. These are not square brackets, but they are the curved ones. So this one is the domain of what? Of the domain of what? Of the polynomial function. So it's always like that, people. If you're given a polynomial function and you ask the domain, you must know that it's how you're going to write it. You're going to write it in this manner, or you're going to write it in this manner. And then, people, we go on to the next function. The next function is called what, people? It's called what? A rational function. It's called what, people? A rational function. Rational function. It's called a rational function. So please, people, you need to know what is a rational function. A rational function, people. A rational function is a function that is made up of two polynomial functions. One function is a numerator and the other one is a denominator. And both of them, they must be what? A polynomial function. So the example of polynomial function, of a rational function, is what, people? Is your 2x plus 1 over your what? Your x to the power of 5, x to the power of 2 in this case, plus 5x plus 6. So this is what, people, is a rational function. As long as these two function, people, as long as these two function, people, these two are what? A polynomial function, and then polynomial function, and then we will call, or we will label that function as a rational function. So you must be really careful, people. So now, how? The other one, people, the other example, because there are many, like they are really different, because I don't want you I don't want to restrict you guys. I don't want you to be restricted, people, because of different kinds of function, people. The other type of function that is of rational is this one: 2 over x squared plus what? Plus 6. So this is also what, people, is a rational function. Because remember, 2, people, is made up of 2x to the power of what? 0. Can you see that? So this one is also what? A rational function. A rational function, this one also. This one is also a rational function. So now, how do we find How do we find the domain of this type of a function? This is how you find it, people. Domain is all the values of x, but not when the bottom function, not when the bottom function is equal to what, people? Is equal to 0. Meaning all the values of x, people, they apply in these types of function, which are rational function. But the most important thing, people, is that but, because it restricts. But, people, not when the bottom function is 0. So we exclude when that function that is at the bottom is equal to 0. So how do you write it now? You can write it like in this way, people. X is an element of real numbers, but x but bottom function must not be equal to 0. So this means you're going to calculate, people, you're going to find where this function will be 0, and then where it is 0, you exclude those points. You say x is an element of real numbers, but x must not be those 2 values or 3 values. It will depend what type of a rational function are you given, especially the bottom part, the denominator. It will depend on the denominator, what type of a function are you given. So we want the function will exist anywhere, but it won't exist where the bottom function is equal to 0, because when you divide with anything with divided to 0 is undefined. So that's how you really write it. X is an element of real numbers, but we exclude where the bottom function is equal to 0. We exclude those points. Meaning x must not be equal to 0. Meaning we're going to solve this, it. Take the bottom function and solve it. And then those values that you are going to get, let's say we solve maybe the bottom function, and then you find out that bottom function at x is equal to 2, it is 0. It cuts your x-axis. X is equal to maybe 6. Then how are you going to write it? You're going to write it like this. X is an element of real numbers, but x must not be equal to 2, and x must not be equal to 6. Are you with me, people? So we exclude those points, because in those points our bottom function is 0, and when you divide anything with 0 is equal to is undefined, that thing. So the next function, people, we are going to look at, the next function that we are going to look at, it will be radical function. Radical functions. So radicals, people, these are sets. These are root functions. I'm putting, people, this thing because these are root function. I'm putting this because I don't know whether I'm speaking mathematical language in this case. So a radical function, these are the function that have what, people? These are the function that have what? The square root. They are placed under square root. These are polynomials that are placed under what? A square root, people. So these are sets. So the first example, people, that will be given, maybe let me start with this clear one, simple. This is a type of a radical function also. This is also a type of what, people? A radical function. This is also, people, another one. This also is another one. This is also another one. So these are the type of function, people, that you can get. We call them a radical function, people. Polynomials that are placed under what? Polynomials that are faced under what? They are placed under a root sign, people, or a radical sign. But there's the most people important thing that you need to get. You have to know. You have to know these, people. You have to know this. So before I can really give you the way on how to find this types of function, is that if people, let's say you have what, people, you have a number a that is placed under a nth root. People, you must be careful. Let's say now your n is what? Is even. And then you must know if n is even, maybe your n is even. When I'm saying n is even, I'm talking about your 2, your 4, 6, 8, 10, and going on, people. If your n is even number, is an even number, people, your n is what? Is an even number. And then for this thing to make sense, your a needs to be greater or equals to 0. Write it down. It's very important. It's going to, I believe that's where you need to start. So your n, if you're given a function or anything, people, or any number that is under a nth root, people, that number needs, if n is positive, if your n is an even number, then your a needs to be greater or equal to 0. Because once it's going to be negative, it's going to be a what, people? A negative sign. It's going to be undefined. It's going to be undefined. Then the other one, people, the other one is that if you have what, people? A number or a function, people, b under m root. And then you find that, oh, my m, people, is what? Is odd number. And then for this thing to make sense, b can be anything, people. It can be negative, it can be positive. Because you will always find an answer, people. You will always get an answer. It will always make sense. So you need to distinguish these cases, people. You need to distinguish the people. So let's go on. So this means now, according to what I've written here, people, This is very important, people. This is very what? Important, because it will help us conclude. So check this. You need to check the root sign of that particular radical function that will be given. If it's of a positive, the root is of a positive number, and then you know the whatever that is under that root sign, it has to be what? It has to be positive. So if it is negative, if it is of an odd number, and then it has to be the real number. So this is how you're going to write it. Check this. You check whether the root sign is of even or odd. That's the first thing that you need to do. Of even, these are what people, the root sign maybe of 2x. These are what people, the fourth root of what maybe? X squared minus 4. Because the number here, people, they are what? They are even numbers. Then how do you find that? This is how you're going to find it. Then the domain, their domain, a domain, x is an element of real numbers. But the f or the function under a root sign must be greater or equal to 0. If the root sign, people, if the root sign is of an even number, and then the domain is that x is an element of real numbers, such that the function under a root sign, people, must be greater than 0. So for instance, this one, x is an element of real numbers, but you must find the values where, but the most important thing is that these values, they must be real, they must be real, but x squared minus 4 must be greater or equal to 0. Because remember, what did I say, people? We say that, people, with here, if it is of an even number, so if it's of a root, the root sign is of an even number, people, then whatever that is inside needs to be positive or equal to 0. Then number 2, if now the root sign is odd, these are your 3, 6, 9, 7, all these numbers, people. Maybe for instance, this is the case, 3, 4x minus 2. Or maybe ninth root of maybe 3x squared minus 2x plus 9. These numbers, they are odd. These numbers are odd, meaning the root sign, people, is of what? Is of an odd nature. This is how you're going to write. Yes. Is that the x values, people, of the function here, people, they are what? They are real. It can be anything. It can be negative. Whatever that is inside here, it can be a negative or it can be a positive. It can be a 0. You will be able to find the answer. So this means x is an element of real numbers in this case. Because a square root of a negative is undefined. But if the root sign is of an odd, and then a negative sign is still applicable. So this is it, people. So I'm going to end this video, then look out for part 2 that is going to follow, because I don't want to make these videos too long, people. So the video that is following, people, I'll also be continuing with this. I'll be doing whereby now there is a mixture of functions. There is a mixture of function, meaning there's a combination of these types of 3 functions that I've just said, I've given you, people. Remember, we dealt with polynomial function, and then we dealt with what, people? We dealt with what? We dealt with a rational function, rational functions, and then the lastly, people, in this video I dealt with what, people? I dealt with radical functions. So the video that is coming, that will be following this one now, will be the combination of these functions. It will be the combination of these functions. It will be the combination. So it's either they'll mix this one with this one, they'll mix this one, No, not really this one and this one, people. No, I'm making a mistake. It's either they will mix this one with this one. Mostly, it's this one and this one. So let's get it on, people. Let's get it on. So make sure, people, to like and subscribe. So this is this 2-part series, people, before I do example. So make sure to do what is right by liking and sharing these videos, people, with your friends. Les Ponchos, Prof Manqanqi signing out. Please look forward to the next video, where I will be taking where I left and continuing forward.